Thanks, Christine. Again, welcome everyone to today's session on automated snow, wind, and seismic loading in Tekla Structural Designer. In this webinar, we'll talk about each of these load types, how to automate them in TSD, ways to apply the load, and some design considerations. So let's start with the snow loading. In Tekla Structural Designer, we have an intuitive snow load wizard. From the loading toolbar, you'll be able to select this command. A dialog box will appear prompting you for information needed to calculate the snow load. You can then create the load cases required for your building. These are the unbalanced loads for sloping roofs and the drift loads at parapets or roof steps. The balanced snow load will be automatically calculated and applied to all roof panels. They'll be placed within the balanced snow load case created by the program. You can view the calculated value by selecting the load in the model. You can also override the calculated value and apply your own if needed. There are a few more steps involved for the unbalanced and drift loads. First, select the appropriate case based on the load type. Second, in the load ribbon, select the load type, either valley, uniform, for a gable, leeward or windward wall, or the option for local drift snow. Third, you'll need to define additional information required in the Properties window for the program to calculate the values. And finally, apply the load by clicking on the corresponding roof panel. Now let's take a look at the wind loading in TSD. In order to have the program calculate your wind loads, you must first apply wall and roof panels around the exterior of the building. These are distribution areas and they tell the program where to place the wind load. They are required even if you have concrete walls on the exterior. Run the wind wizard to input the necessary data for TSD to calculate the velocity pressures, and then generate the load cases to obtain the wind pressures. Finally, you'll generate the wind combinations again that the building will actually be designed for. Just like we saw for automating the snow loads, we need to model roof panels to automate the roof wind loads. Wind loads, including roof uplift, will be applied only where a panel exists. When working with roof panels, you'll run into two conditions. One is if the slab is modeled on the roof. For example, if you actually have a concrete slab on your roof, or if you need a rigid diaphragm defined. If this is the case, you need to set the roof panel property to decompose only wind. Now, if there's no slab modeled, so for example, if you only have a metal deck at the roof, then keep the only wind option unchecked, and you have the option to define a diaphragm or not in that case. We also need to model wall panels around the building, and wall panels must be supported perpendicular to their span direction. Typically, these can be modeled as a single wall for the full height of the building for an entire planar surface. However, if you have a parapet, this needs to be modeled in its own wall from the roof to the top of the parapet. Now there are three options for how the wind panel will ultimately apply the wind loads to the building, and these are decomposed to nodes, members, or rigid diaphragms. The nodes option will apply the wind loads as point loads at the column nodes. These point values are numerically the same regardless of the span direction of the wall. Therefore, the span really is irrelevant for the distribution option of nodes. It usually makes sense to keep these walls spanning horizontally or side to side because the columns can then support the wall themselves and you don't have to put in any extra dummy members. Now, if you don't have columns at the edge of the walls, then you will need to support the wall. In that case, I typically recommend spanning the wall vertically or up and down and adding dummy beams at the foundation. And make sure to support those dummy members with fully fixed support elements to maintain model stability. It also can be helpful to create those dummy members out of elements and just make sure that you input the properties correctly for those elements. The second option is to distribute the wind loads to members. This will apply the loads as line loads directly on the members in the plane of the wall. Select this option if you want to design wind girts, for example, where you actually want to check that beam for out-of-plane wind loads. In that case, the span direction of the wall does matter, and you'll want to make sure that it's perpendicular to the member that you want to design those out-of-plane wind loads for. The final option is the rigid diaphragms. This will apply the wind load as point loads directly on the slab diaphragm. The slab will then distribute the load based on relative rigidity to the framing members. The diaphragms must be set to rigid for this option. The span direction here again is irrelevant, so you can just have it spanning side to side as the default. The distribution method that you select will determine how the wall panels need to be modeled. The nodes and member options require you to follow the contour of the building. So think of this as shrink wrapping the building, and that's kind of the option shown here on the left. One benefit of the diaphragm option is that you don't have to follow the building outline. You can simply create a box around the extent of the building, and that's the picture that's shown here on the right. Once the wind panels are modeled, you can run the wind wizard. Similar to the other loading wizards, this will contain a series of dialog boxes where you can input the necessary information for TSD to calculate the forces. After going through the wind wizard, you must generate the wind load cases. This is also automated, and you simply select which cases are required. Finally, you must generate your combinations, and this will add the lateral wind load combinations to the previously generated gravity ones. Once the wind loads are created, you can easily view them in the wind view. Right-click on a 3D view and go to wind view. There you can scroll through the wind direction and the corresponding load case to see the actual pressures applied to the building. This removes any ambiguity and allows you to directly manage the calculated pressures. You can click on a pressure to view its properties, and then you also will have the option to override that value with your own value if you need to. Another important aspect of designing for wind loads is the drift limits. TSD allows you to set wind drift limits for each individual column. This can also be done easily when modeling by setting up the property of the column prior to modeling it. In the Show Alter State, we have the option to manage the drift limits graphically. You can find this command in the Review view. In the Properties box, select the Wind Drift option. Then work through the properties to set different wind drift limits, turn columns on or off to be even checked for drift at all, or simply review what's in the model. And you can do all of this by clicking on the columns after setting the options within the properties box. You have the option to select if the wind drift is checked against each wind load case or the entire load combination. Now, we have spoken with lots of different companies throughout the country on this topic, and there seems to be about a 50-50 split over whether engineers consider just the case or the full combination. So we've given you the ability to select which one you prefer to do, to check for cases or combinations. Now, either way, the program will look at the wind combination and use the service factors for that combination to calculate the drift. If check wind cases only is selected in the design options, the drift will be calculated for that single wind load case with the factor. If this option is unchecked, the program will calculate the drift based on all the cases in this combination. But so for example, here on the screen, if wind cases only is checked on, then the drifts are going to be calculated based on this wind load case number 11 with a factor of 0.6, which is appropriate since these are strength level wind loads and we want to factor them down to service level loads. Once a design is run, the status tab will tell you quickly if the columns pass the wind drift checks or not. Any columns that fail will be listed under the drift check with a red X. You can then get more information by going to the tabular data in the review view, turning on the wind drift view type, and scrolling through each load combination to view the results. Again, although you're looking at the combination in the loading toolbar, whether the results are for the entire combo or just the load case is controlled by the design options that we just discussed. Lastly, let's talk about seismic loading. And we'll see that the seismic loading is the most automated of the three, with all the steps for loading contained within the wizard. And as we've seen, and you're probably already expecting, we're going to start by selecting the seismic wizard from the loading toolbar, and a series of dialog boxes will walk us through the necessary information that it needs to calculate the seismic forces. Most of these are taken straight out of the ASCE 7 code, making it easy to understand and work through. And you'll also have the ability to indicate which load cases will be used to calculate the seismic weight. Here you can create special load cases to use for only this purpose and not to load any of your framing members for gravity. Finally, as you work through this wizard, it'll automatically open the combination screen and add the seismic combos to those previously created. Now at this point you could run the design and check your members for seismic forces. However, if applicable, you can also assign framing members to a seismic force resisting system. These members will then be checked for the additional seismic provisions of AISC 341. Similar to what we saw for wind, the status tab will give us an overview of the seismic drift. A green check mark here will indicate all the columns passed for seismic drift checks. These checks are built into the program and are fully automated based on ASCE 7. If any of the columns fail for the drift check, they'll be listed here under the seismic drift category, and you'll be able to see what columns they are. You can also see more information by opening the tabular data in the review view. You can review worst case conditions for each column in the summary table, or click on details to get more information for each load combination in each direction. And there you can also see the allowable drifts that are calculated by the program. Okay, so now let's go ahead and open Tekla Structural Designer and take a look at how this works and how we can automate and apply the loads to our building. Okay, so here I've already modeled this building, three-story building, concrete on the bottom, steel on the top, and I've already applied my roof panel so that we can get the loading. Now just to show you, I already have some dead load applied on the building as well as some live load. So now we're ready to start with the snow load. So in the loading ribbon, I can click on the snow load command and run through the snow wizard. So here just make sure that you input basic information about your project and the ground snow load. Next, you can define the wind load cases. If you need a minimum snow load, maybe the calculated snow load is 15, but your jurisdiction says you can only do a minimum of 20, you can also create that load case. Now the balanced load case, that one you probably always want to keep to yes, just because that's going to put the snow load right on your roof panels automatically. And then the unbalance and the drift depends on the conditions in your building, if you have those conditions or not. You can also generate a rain on snow surcharge if you need that for your area. Now once I click finish, notice that the load cases have been created here in the loading toolbar, and if I switch to the balanced snow load, it has already calculated it and applied it to the roof panel. And I can hover over it to see the value 21 PSF. I can click on it, view the information in the properties window, and I can also override the value and put in my own value if I need to. For an unbalanced snow load, I don't really have that condition here because it would be for a sloped roof, either a valley where two low points meet, or something more like a gable where it meets at a high point. But in that case, you would want to choose the uniform for the gable or the valley for the low point, and then input the information here in the properties window and simply click on the roof panel for those conditions. Now we do have a short video on our website that goes through the snow loading in more detail, so if you want to see that done for the gable or the valley condition, go ahead and take a look at that short video on the snow load wizard. The final one is the drift snow load. So select that load case from the loading toolbar, and then in the ribbon choose your local drift snow. And here this could be a step, so if your building has a physical step in it from where it goes from a low point to a high point, you would choose that. Or you could change this to parapet or projection. Input the parapet height and the length of the roof in the direction of that parapet. Now, when you hover over the roof panel, notice that the edge of the panel is highlighted. So that's the edge that the drift is going to occur on. So click on the edge, and now you can define the extent of the parapet. So if it doesn't occur along the entire length of the roof panel, you can apply it to just a portion of it. And this would be great also if you have a screen wall that maybe is only on a portion of the roof. You can define this just on that portion where it occurs. So for example, I'm just going to click from that starting point, to the end of my roof, and you can see that it calculates the drift for that section that I've identified. And if I hover over it, I can get information on those load values, or I can click and see that information here in the properties box. And you can see what the drift value is, what your drift width is, and again, for either of those, the drift or the snow load, you can override those values. So now let's take a look at the wind loading. And for this one, we've already added our roof panel, as I mentioned, but in this case, I also have slabs on all of my levels, including at my roof. So if I click on my roof panel here, let me grab the actual roof panel, there we go. You can see that I have the decompose only wind selected because I have a slab that's acting as my diaphragm, and the slab is what's distributing the gravity loads. So for the wind loads, I need to check this on. Now the second part is creating those wind panels. So I'm going to turn that view on, and I've already created two of them here. Now one option is I would actually have to follow the perimeter of the building and model these wall panels on each surface. The other option, since I have a rigid diaphragm at my roof, is I can use the rigid diaphragms distribution method. So in that case, I'm going to open up my base plan, and I want to create grid lines that form the extents of the building. So I'm going to use these existing lines and just extend the grid lines out to form a square. Now I'm going to select my fourth level, or just the highest level, and in the properties I'm going to say show the grids in 3D. And back in the 3D view, I'm going to turn on my grids. So now you can see the grids at the top there as well as at the bottom. And that now gives me snap points where I can model the wall panel. So I'm just going to click to the corners of the building, the full extents, and I can just create a bounding box. I don't need to follow the exact shape of the building. I'm just telling the program, within these extents, find the rigid diaphragms and distribute the wind loads into them. So it will actually distribute it correctly into these sections that don't touch the perimeter wall. Now I can run the Wind Wizard. So in the loading ribbon, I'm going to click on Wind Wizard, and I can walk through putting in the information. Now some of this will come from the model itself, like the highest levels and the building extents, but you can override those values if you need to. And you can also change the ground level of the model. So for example, if you have a basement or a hill or anything going on where maybe the base of the model is not the actual wind base, you can change that. And also if there's anything else that you kind of want to account for. And the orientation, if your building is angled to the main building orientation, so right now an orientation of 0 means that wind in the X is going to follow the global coordinate that you can see here on the bottom of the screen. And if I were to rotate this by any angle, that will now be the angle that the wind in the X direction, or direction 1, is going to be at that new angle based on what I've input here. So for some buildings, it might not make sense to follow the global X and Y coordinates. You might want to apply the wind in a different coordinate. On the next screen, input your basic wind data. and this is pretty self-explanatory, just the information that you need to calculate those wind values. And notice here that I can apply an exposure category and a topographic feature in each of those main wind directions. And so that's nice if you do want to maybe fine-tune your uh, calculation a little bit. Maybe if you're checking an existing building, or maybe you're doing some value engineering and you really want to be tight with the loads, you can apply the condition to each surface instead of just the worst case. Finally, this is going to give you the velocity pressures. You can click on details to get more information on how those are calculated, or at this point you could just click finish. So we've gone through step one, we went through the wind wizard. The next step then is to calculate our wind load cases. And again, this is also automated. We just need to tell the program what direction we want these to be created for. And you can of course do it for all of them. However, this is going to create hundreds and hundreds of combinations, and it will be a little bit slower to run the analysis and design for all of those. So if you know that one will control and another one won't, you could start maybe by having just a few cases selected, and then you can always come back and set all of them just to do kind of a final design, just to make sure that everything still works. So I'm going to go ahead and say OK. You can review it again on this screen and click close. So now I need to regenerate my combinations, and if you notice I just have a single gravity combination because that's all I had in the model up to this point. So now I need to click generate, and I'm designing this building to LRFD, so I don't need to create any of the ASD combinations. I can just generate my LRFD combos. And I don't have any roof live loads, so I'm going to get rid of those and just keep the combinations with dead, live, snow, and wind. Okay, so you can see the number of combinations is really starting to build up, so that's why you may or may not want to generate every single wind load case. Now I can switch to the wind view, and I can toggle through my wind direction. So let's say wind in the X, and then select my load case here at the bottom of the screen, and I can turn on the net pressures, and you can see exactly what is being applied to the building, and you can see it for the roof as well. And so maybe one of these you want to be a little bit more conservative. Maybe I just want to set these all to be the same, so instead of -13 at this roof corner, I just want to do everything 20. I can click on that, I can uncheck the default and say, you know what, let's do an uplift of 20.7 to match the rest of the roof. And then that's what will now be applied to the building. Okay, so you have complete control. You can see exactly what the program's doing, exactly what wind loads it's applying, and then you can also change those if you need to. You have the ability to make those engineering calls. Now the other thing we can do if we go to the review view is we can go to the show alter state, change the attribute here to wind drift, and we can review what columns are being checked for wind drift or not. So you can see right now these columns are shaded in white, are not going to be checked for wind drift, so maybe those are just some interior columns that are not really doing much. They're just going along for the ride, and I don't really need to check them for wind. But then these exterior columns are all turned on, and so those are being checked for the wind drift limits. And then I can come in the properties and I can set on to see, you know, which ones are on, which ones are off. I can set my limit, and right now I'm looking at a limit of 300, which is the default. And so you can see a lot of these are set to 300, which is the purple color, or excuse me, the orange color. And then this beige color, these are some other limit. And so I can say, okay, well, let's say 600, and now those are orange and the rest are all the beige. So I know these are set to H over 600. So maybe I just have some brick at the front of my building that I need to be a little bit stricter with my wind drifts as opposed to the back of the building. So kind of some ways that you can graphically review this and set this information up for your wind loads. So now I'm ready to design the building. And at this point, I would recommend that you run the full design either for just the steel, just the concrete, or both if you use the all, because the program will optimize for wind loads. So it actually will pick section sizes for you based on your wind loads. And that way you can have a good starting point for your lateral members when you're going into your seismic design. For seismic, we can't optimize for the sizes. We have to have the sizes first before we can calculate the forces, and then it's just a design check thereafter. But for the purpose of time and really presenting what we're concerned with in this webinar, which is the loading, I'm going to go right into the seismic loading. So in my loading toolbar, I'm going to go to seismic load and click on the wizard. Again, this is just a series of dialog boxes that will walk me through the necessary information to generate these seismic forces. So put in your earthquake spectral response acceleration values here, and notice that these are in %G, so make sure that you put them in as a percent and not as a decimal. The next screen is basically just a checkbox for you, the engineer, to make sure that you understand what's going on in the building and that you're using the appropriate seismic method. So if you know that you have an extreme soft story, a weak story, there we go. Depending what you have here, the program will now tell you if the equivalent lateral force is still permitted or not, and what else you need to do in order to properly run the design. So I think maybe if I have extreme torsion, the equivalent lateral force procedure can be done a lot. So one of these combinations will say, oh, there we go, the modal response spectrum analysis is now permitted. So that's what you have to use. So you can see now ELF is grayed out and you must use RSA. So this is a checkbox for you to make sure that you've correctly selected either ELF or RSA. On the next screen is calculating the fundamental period of the building. So put in your long period transition and your structure type to calculate the approximate period, and that's going to be used with ELF, and that's usually appropriate for the equivalent lateral force procedure. If you want to calculate the actual building period, you can choose the vibration analysis option, or if you've already calculated the period, you can choose a user defined and just put in what it is. Now on this screen, we need to tell the program what the lateral force resisting system is in each direction. So in this one, for my X direction, I have moment frames, and you can choose what these are. This is straight out of the code, and then the program will calculate what your coefficients and factors are below, and these will be automatically applied where appropriate. The same here in my other direction, maybe I have a building frame system, and these are special steel concentrically braced frames. Now the only thing that's not automatically applied is the overstrength factor. That is usually kind of a member by member case, so it's not going to be automatically applied universally to the program. Now the one time that it will be automatically applied is if you put a column specifically in or a beam or a brace, depending on if it's needed or not, in a seismic force resisting system within its properties, and then if the overstrength factor is required, the program will automatically place it into that member to design check it. Okay, but it's not going to apply this universally to the whole structure, which is what you would expect. That's what you would want. On the next screen then, this is where we can identify how to calculate our seismic weight. So I can use the toggle to add those cases, and you can also add some live cases or snow if you need to, and then you can add a factor. Let's say you just want to include a small percentage of that load, you can do that. Now here you can also create special load cases for additional seismic weight. Let's say you have some self-supporting brick, some interior masonry walls that are not loading any of your framing members that you're designing in TSD. You can create a load case for those, apply the load in that load case where it actually exists around the building. Don't include that load case in any of your gravity combinations, but simply add that load here on this screen, and then you can account for that to calculate the weight of your building. So I'm going to click Finish, Now I can choose to add those two combinations. And if I open up my combination box, you can see that the seismic combinations are indeed already added at the bottom. So I don't have to completely regenerate them like we did for the wind. So for the seismic, everything is automated. It's less steps than we had for the wind loads. Now the final step here, if we do have a special lateral force resisting system, we can actually have the program check those. So I can select these braced frames, for example. I can come into the properties and I can turn these on to be in the seismic force resisting system. And I can say which direction they're in, 1 or 2, and then what type of system it is, special concentrically braced frame. And now the program will design these for those additional provisions, or not really design, but do a design check to see if they still pass or fail based on those additional provisions. Okay, so once we have all of that, we can go ahead now and run our design. So I'm going to run a design all, and I usually do like to open up the show process window before doing this. That way you can see exactly what the program is doing while it's running through the analysis and the design. Instead of just looking at this please wait dialog box, you can actually see, okay, it's at 75% of the design, or it's running through the checks, or whatever it is that it's doing. And again, you could be optimizing for the wind load cases here. It would pick all of the sizes for the wind, and then it would do a design check for the seismic. So we shouldn't be surprised if there are members failing once this is done, because it could probably be failing for the seismic loads. So let me just turn off the wind panel so we can see a little bit more clearly. So there we can see, we shouldn't be surprised. These columns and braces that we put into our seismic force resisting system are failing, and if I check them here, we can see that it's failing for this seismic check for the compression. And you can go through, you can look at all the equations, code clauses, and you can see exactly what's going on with the design for those additional seismic provisions. Now notice here in the status tab we have the design information for our seismic drift and wind drift. And in the review view we can click on tabular data. We can change the output here to be seismic drift. We can review what that is for all of our columns. We can click on details to get more information about what the drift is, what the calculated allowable drift is, and a ratio to see if it's passing the limit or not. And we can do the same for the wind drift. Now for this one though, you do need to select the combination, and you'll have to scroll through your different combinations. But again, if I go to the design options and go to wind drift, I have this checked on for wind cases only. So these drift values correspond to the single wind load case in that combination with this factor applied to it. And so you really don't need to check all of these combinations because a lot of them will actually be the same. And maybe you only have to check these few here where you have 0.6 wind if you're only looking or only concerned about the load cases. Okay, so just something to be aware of and something to think about as you're working through those. And lastly, we can review what information or what loads are actually being applied to the building for the wind and the seismic. So if I turn on just my decomposed loads in the scene content and then go to one of my wind load cases, and let me turn on the text, we can see the point loads that are being applied. So again, I use that diaphragm option, so it's a single point load at the diaphragms. And then here too you can see the uplift that's being applied on all of my roof beams. For the seismic load, we need to switch to the results view and look at one of our seismic directions. And then here under seismic, we can turn that on and we can see what loads are actually being applied at all of the column nodes for our seismic forces. And lastly, we can print a report with all of this information. So if you go to the report ribbon, if you go to the building loading, you can get information about the wind. And if you go to the seismic design, you can get a report for the seismic forces, how those are calculated, and then all of your story forces, as well as the drift information here as well. Okay, so that brings us to the end of this webinar on automating snow, wind, and seismic loads in Tekla Structural Designer. Thank you everyone for participating. If you have any questions, please contact our support department at tekla.support.us@trimble.com. And also feel free to contact me, Monica Rennick, at trimble.com or monica.rennick@trimble.com. And depending on your question, I might just forward it along to our support department or I can help you out directly. So thank you again, everyone, and have a great rest of your day. Goodbye.